In this video, I'll explain equal cost multipathing using the NSX Edge. So we'll talk about the equal cost multipathing support and what capabilities the NSX Edge can provide. We'll talk about what happens when a failure of the NSX Edge occurs if we have an ECMP configuration. And we'll also talk about compatibility issues with this feature. So as of NSX 6.1, equal cost multipathing is now supported, and traffic can traverse multiple edge gateways in a balanced manner. This method offers higher bandwidth, supporting up to 10 gigabits per second per edge, and a maximum of 8 NSX edge gateways can be deployed in this model. In this type of deployment, all of the NSX Edge instances will form a neighbor relationship with the logical routing control virtual machine. So here we see the DLR control VM, and all of the NSX Edges are going to form a routing peer relationship with the DLR control VM. And each of the edges will also form a neighbor relationship with the physical router as well. These dynamic routing protocols will help us recover from failures. So let's talk about what happens when an NSX Edge fails and we have equal cost multipathing enabled. So in this scenario, we have traffic that's being distributed across multiple unique NSX edges. Right? These edges don't have any relationship with each other. There's no synchronization or sharing of state information between the NSX edges when they're in equal cost multipathing mode. And that means that if an edge fails, all of the traffic and all of the link information associated with that edge also fails. And let's assume that the DLR and the NSX edges and the physical router are all using OSPF. Well, what this means is that if an NSX edge fails, an update to the routing table is going to occur. And the faster we can get this routing update pushed out, the sooner that traffic will start flowing again. So this is very different than NSX Edge stateful high availability. Stateful high availability gives you an active and a standby edge, and there's almost immediate failover. With NSX Edge and equal cost multipathing, we want to set a very aggressive dead timer with our routing protocol so that if an edge does fail, the routing protocol will detect it really quickly and alternate routes will be used for that traffic. Now, OSPF and BGP both support dead intervals as short as 3 seconds. The NSX Edge in equal cost multipathing mode is incompatible with some stateful features such as the NSX Edge firewall. So let's take a look at an example. Here in this diagram, let's say that virtual machine 1 generates some traffic bound for an external network. Maybe somebody goes in, opens a web browser, and points to a website like trainertests.com. As that traffic flows out, it's going to hit the NSX Edge. And the NSX Edge will analyze the firewall to determine if that traffic should be allowed out or not. And if it matches a permit rule in the firewall, then yeah, that traffic's going to be allowed to flow out to the external network. Now some response traffic comes back, but this time, instead of hitting the NSX Edge instance that is aware of the current state of this connection, because we're using ECMP, the return traffic might actually flow back in through a different edge. Equal cost multipathing supports routes through multiple edges to and from the same destination. So that return traffic might potentially come in through a different edge, and that other edge may not be aware of the state of that connection, and it might block that traffic. So that's just something to consider if you're possibly thinking about utilizing the NSX Edge in ECMP mode. Now let's take a look at how this behaves within a high availability cluster with 3 or more hosts. So notice that we have 2 virtual machines on 2 different hosts. And there's 2 different shared storage systems also available down here at the bottom of the screen. And all of our hosts have access to all of our data stores. And this is important, and it's of course is recommended as well. So let's assume that the host that Edge 2 runs on fails. Something happens to that ESXi host and it's no longer functioning. Well, the files of that NSX Edge are still intact on the data store. We can see the files for that virtual machine are still sitting there on data store 2 and are accessible to our other ESXi hosts. So this means that vSphere high availability can bring up that failed edge on another host. Right? That edge can come up just like any other virtual machine could. The edge can now reestablish those neighbor relationships, and we can begin equal cost multipathing again. One final consideration to bear in mind, here we see a couple of NSX edges. I've labeled them active edge or standby edge, but in reality, they could both be independent edges configured for equal cost multipathing. Regardless, I want to make sure that these edges stay on the appropriate hosts. There's not really a whole lot of point in doing equal cost multipathing and having multiple edges if those edges get moved by DRS and end up on the same host. So we want to create anti-affinity rules to govern that these virtual machines should not end up on the same ESXi host. Right, so now we can see in this cluster, maybe we have fully automated DRS enabled. And so what has happened here is both of these VMs, both of these NSX edges have gotten migrated to the same host. And if that host fails, well, now we're out of luck because we've lost both of our NSX edges. So of course we want to create some management controls that prevent this. And the way to accomplish that is to configure a DRS anti-affinity rule to force those edges to remain on different ESXi hosts. So in review, the NSX Edge now supports equal cost multipathing as of NSX 6.1, and this allows us to balance out the egress traffic workload over multiple edges and multiple ESXi hosts. There's no synchronization, there's no stateful failover, there's no active and standby. Each one of the edges is independent virtual machines and they don't synchronize with each other. And if one of them fails, the network will heal itself using dynamic routing protocols. So we want to set very aggressive dead timers with equal cost multipathing so that if a failure does occur, the failover happens very quickly. And again, ECMP is incompatible with stateful features such as the NSX Edge firewall and network address translation.